I wonder what this video is about.
You have to learn
To pace yourself. Oh, speed equals distance over time.
you just
Like if, no I'm not. No I'm not. Pressure, force over area.
you've only had to run,
Speed equals distance over time, run.
but you will come to a place where the only thing
Nice song, what an awesome song. Pressure. Gee, that's what we're gonna talk about today. Pressure! Woo! Yeah! All right, here we go. Let's do simple calculation here. Now I'll get it on my tripod, of course. So here, look at all that mess. Oh, wait a minute. Hold on. This is live. You're seeing me try to handle this horrible camera. Whoops. Wait a minute. Let's see if this will work. Maybe a calculator cover might work as a good tripod here at Springford 8th Grade Center. Quality equipment. Whoops. Wait a minute. Ah! Wait a second. It's almost there. Talking about pressure. This is pressure right now trying to get this thing to work. Yes! Yeah! Okay, here we go. Let's zoom out a little bit. Zoom in. Perfect. Okay, all right, let's talk about pressure. Here we go. We turn off that music. Here we go. That would be Billy Joel, Pressure. And Queen had a song, Under Pressure, I think it was called. Good stuff. Okay. Pressure. We talked about pressure being the amount of force applied over a given area. And we talked about how if you're standing, right, and you're standing on your 2 feet, that's the surface-to-surface contact. The bottom of your 2 feet is the area at which your weight is being applied. So now, get here. At home, do it. Stand up. Now, stand on 1 foot. You've decreased the area at which the force is applied, but the weight is still the same. Your pressure increases. Now stand on your tippy toes. Whoa, jeez. Whoa. Oh. More pressure. And more pressure. Can't even stand. You get my point. So it's the amount of force over a given area that determines pressure. We will talk about, or have talked about, air pressure, fluid pressure. As you increase, as you go to a higher altitude, air pressure decreases. As you go to a greater, deeper depth in water, pressure increases dramatically. We'll talk about that in class if we haven't already. But right now, let's just do a very simple calculation. We talked about pressure in the gas laws way back when. We talked about Boyle's law. Go PV! As pressure goes up, volume goes down. It's an inverse relationship, assuming a constant temperature. And we also talked about Gay-Lussac's law. Pressure and temperature are a direct relationship. They both increase and decrease simultaneously. Okay? And that's that. All right, let's talk about these problems real quick. They're very simple. You have the formula. You have the units. Back in the day, we used kilopascals and atmospheres for pressure. For this, to keep it simple with our book, we'll use pascals. Okay, I'm just going to do the first 2 problems, and you guys, I'm sure, can figure out the rest on your own. A box has a weight. There's your gravitational force. Your weight, which is the force of gravity, is 120 newtons. And the bottom of the box has an area of 4 meters squared. Okay? What is the pressure? Gee, guys. Weight, and this is force. Okay? Weight is gravitational force. All right? So, how do we do it? Plug it in. I'm sorry. Second box. Formula. Pressure equals force over area. Third box. Let me adjust this real quick. Pressure equals the amount of force is 120 newtons divided by 4 meters squared. And I'll put the 4th box down here just in case. Pressure is going to be 30 pascals. Let's take a look and see if that shows up on the camera. Looks good. I'll zoom that in a little bit. There you go. All right, I just have room for the 4th box, but that's fine. Okay. So let's take a look at this formula again. Let's take a little bit of time and look at the relationship. Let's work with the easy numbers. So if I have pressure, I'm going to manipulate the formula. we see that force is directly related to pressure, area is inversely related to pressure. Okay, so if I were to increase the area, what would happen to pressure? And assuming we kept this constant, if I made this value bigger, the pressure would decrease. If by chance we use the same formula, right? And I decided to decrease the amount of area that the same amount of force is applied on. So less area, less interaction, same force, pressure goes up. So as one value increases, the other value decreases. As one value decreases, the other value increases. Now, you see that relationship right there. Now look up here. Let's say I've got the formula again, right? And let's say we kept the area the same, we'll keep that the same. And let's say for some reason the force would increase. Well, force is directly related to pressure, so would the pressure. And if we decrease the force over the same amount of area, pressure would decrease simultaneously. Okay? So I would really think about problems where I say, here's your what is the pressure? Here's your information, but we increase the amount of force by 4 times over twice the area. 4 times the force over twice the area, how will pressure change? 4 divided by 2 is 2. You would have 2 times the amount of pressure. Okay? Or vice versa. Take a look up here. Let's say we cut the area in half. Keep this as is. Cut the area in half. So we halved the area. This is an indirect relationship. So this becomes twice the pressure when you half the area. Apply the same force over the half the area, you get twice the pressure. Again, this gets smaller, this gets larger. This gets smaller by a half, inverse relationship. This then, because of that, doubles. Please understand that. That is probably more important than the actual manipulation of a simple division problem. Okay? So keep that in mind. You will get nailed with that on a test, I'm sure. Okay. Second problem. Let's go with number 2. A bronze statue weighs 2,400 newtons. The base is 4.5 meters squared. What's the pressure? Again, plug it in, and write the formula. Pressure equals force over area. Pressure equals 2,400 newtons divided by an area of 4.5 meters squared. Get a calculator. 2,400 divided by 4.5. You're looking at a pressure of 533 pascals. 533 pascals. So then if you manipulate this formula and you apply the same amount of force, right, over, let's say, 4. Instead of 4.5, we'll say 4, right? If you apply that over 4 meters, your pressure would then become 600 pascals. So when you decrease the area, this value goes up. We went from 533 to 600. And initially this was at 4.5 meters squared. This would be at 4. What if I distributed that weight over 1 meter? If we distributed it over 1 meter squared, you obviously have 2,400 units, pascals of pressure. So you see how that formula works, okay? Very simple manipulation. You guys do that. We'll talk about, if we haven't already, altitude and air pressure and liquid pressure in deep depths of water, okay? And we talked about earlier this year, pressure depends on the number of elastic collisions amongst molecules, okay? Easy, simple, do it, get her done, great job. Okay, that's it. We're gonna make another video. Sorry it's so brief, but we got a lot of videos to make. All right, that's that. Thank you, good job.